Okay, so in this video we're going to describe mass balance in a little bit more detail, and I'm going to show you a way to think about it using an ICE table. So all a mass balance is simply a statement that of the conservation of matter. So it's just when we're doing systematic equilibrium, when we're doing a systematic equilibrium problem, it's just a way for us to use the conservation of matter to write one more equation in our system of equations. All right, and in this problem, we're dealing with calcium fluoride. And calcium fluoride is an insoluble salt. So we're going to label it solid. And when you put it into an aqueous solution, although it's an insoluble salt, there's going to be a very small amount of it that will dissolve. So we'll write an equilibrium expression associated with our KSP, equilibrium constant, that forms calcium 2 plus and 2 fluoride anions. Alright, so normally we would just, if we wanted to talk about the solubility of calcium fluoride, we would just set up an ICE table and solve for our solubility using our KSP. But we have a complication because fluoride, F minus, is the conjugate base of a weak acid. So F minus is going to be a weak base. So this is going to be a weak base. So now we don't just have one equilibrium expression going on. We also have a second equilibrium expression of our fluoride anion reacting with water to form hydroxide and hydrofluoric acid. And then the equilibrium constant associated with this expression is our Kb. So we need to be able to write out a mass balance because the reason why this problem is much more complicated is because we have two competing equilibria here. We have our calcium fluoride dissolving to form our fluoride anion, and then we have our fluoride anion that's going on and reacting with water to form hydroxide. And so we can set up a mass balance based on this equilibrium expression. So we know that, and so here's where I want to use an ICE table. Alright, so I want to set up an ICE table to help you think about this mass balance. So if we have this calcium fluoride in solution, initially we just have some mass of calcium fluoride in our solution, because it's in the solid state, and it's in this equilibrium to form some calcium 2 plus and some F minus, but initially we don't have any calcium 2 plus or any fluoride anion. So then we're going to have our change, and remember that for every 1 mole of calcium fluoride, we're going to form 1 mole of calcium 2 plus and 2 moles of our fluoride anion plus 2. Okay, so I think this change is what will really help you understand the mass balance. So at equilibrium, we'll just continue writing out our ICE table. We don't include our solid in the ICE table, so we're just going to put a line to show that we're not including the solid because the pure solid isn't included in an equilibrium expression. So we just have our x and 2x. So normally we would plug this into our KSP expression, but that's not how we're going to use this information in this problem. Alright, so to set up our mass balance, we can say that the concentration of calcium 2 plus in solution, so here in our equilibrium expression we can see that the concentration of our fluoride anion is equal to twice the concentration of calcium 2 plus. So when we're setting up our mass balance, we have to put a 2 out in front of our calcium 2 plus. So we're saying 2 times the concentration of calcium 2 plus is equal to our total concentration of all of our fluoride species. So I'm just going to put F minus total. Okay, but remember that we also have this other equilibrium expression. We also have F minus reacting with water to form hydroxide and HF. Oops, ran out of room. That's plus HF. So we know that we don't just have F minus in solution. Some of this F minus is reacting with water to go on and form HF. So when we want to include that in our mass balance. So our mass balance will ultimately be 2 times our calcium 2 plus concentration is equal to the concentration of HF plus F minus. So this is our finished mass balance. So this is really important because what we're saying is that some of our fluoride is going on to form HF. So 2 times your total calcium 2 plus concentration is going to be equal to all of your fluoride concentrations. All right, so I hope that cleared up mass balance for you a little bit. And just remember that setting up an ice table might help you to be able to see exactly what species you have in solution for a particular problem and what the different coefficients you need for your mass balance.